Hi everyone, this is going to be a video on solving simultaneous equations using the elimination method. I'm just going to go through 4 questions from these exercises that I picked out, and I've gone and labeled which numbers of questions I've done as well. But I'm hoping that through these 4 questions will give you a decent variety of all the kinds of questions that they can ask when asking about solving simultaneous equations with the elimination method, and then you can do it from there. So starting with this first one, we see these 2 equations, and we do see that they're lined up. Straight away we see that the x's are kind of like vertically lined up on each other. We see that the y's are lined up, and we see the equal signs are lined up, and we see that the right side, the constant, is lined up as well. So it's generally a good place to begin. So you should think, again, step 1 should be lining them up if they're not already lined up. Once they're lined up, we then need to make it so they're identical. Right now, none of them are identical. The x's have a different coefficient, and you can say that the y, they look identical, but you see that the top one is -3 and the bottom one is +3. So what we need to do here is we need to do some kind of multiplication on one of those equations, both of them in some cases, which would make them identical. So what we could do is we could either focus on the x's and then multiply by some number, or we could focus on the y's and then make them both equal +3 or -3. Some of you guys might be looking at this and say, oh, we'll multiply the bottom by 2, and yes, that'll be totally fine. What I want to do in this video instead, though, is just to show a different option, is I'm going to multiply the top equation by -1, and you'll see what happens when I do that. So if I were to multiply this, change these, remember I'm just going to leave the bottom one as is for now. So I've got 2x plus 3y equals 13. So that bottom stays the same. But what I'm going to do, I'm going to multiply the top by -1, like I said. So just write that in. And when I multiply the top by -1, I'm now going to get -4x plus 3y equals 1. So what I've done is 4 times -1 is -4, -3 times -1 is +3, -1 times -1 is 1. And now we see that the y's are identical, the coefficients. So now that one of them are identical, we can now eliminate the y's through subtraction. And so this is what I'm saying, you could have added them at the start, but then you having to remember 2 different methods into the one method. It's just a lot easier to make them identical at the start. So we have here, so now we're going to eliminate them through subtraction. So if I do -4x minus 2x, it's going to be -6x. 3y minus 3y, that goes away, that was the whole point. And 1 minus 13 equals -12. So now I have the equation -6x equals -12. I might just write that again. We have -6x equals -12. And then to get rid of that -6, I'm going to divide by -6. So I get x equals +2. Remember, it's going to be positive because -12 divided by -6 is positive. When you divide a negative by a negative, you get a positive. So now that we have that, but we haven't finished the question yet because we still need to find what y is. So what we're going to do is we can substitute it into any one of those equations that we have along the top. Like I've said, I generally like to choose these ones with the smallest numbers because that generally makes it a little bit easier, but doesn't really matter. I'm going to substitute into that one there. So we're saying that x equals 2, so now we have 2 times 2, which is 4, plus 3y equals 13, and then we just solve this equation from here. So here I want to get rid of the 4 first, so I'm going to -4 on both sides, so we have 3y equals 9, and then lastly, now we can divide by 3, so y equals 3. And therefore my solution is x equals 2, y equals 3. Remember, put a box around your solutions when you're solving equations, because that just makes it easier to see. Going into this next question, again, we have 2 options here. We can either, well, first of all, they're lined up, that's good. Second, we need to see if they're identical and they're not. So we're either going to need to change something with the x's so that they look identical, or change something with the y's. So there's 2 options. I could either multiply the top by 4 because that would help me eliminate the x's, or I can multiply the bottom by -3 because then I'll have +3y on the bottom, and then again I can eliminate. What I'm going to do this time is I'm just going to multiply the top by 4 just to show like a bit of a different way. So I'm going to multiply the top by 4. And by the way, just to be clear, you don't always need to multiply the top. Like in this question and the previous question, I've been multiplying the top, but there's no reason why it needs to be the top one. So I have 4x plus 12y equals 36, and I have 4x minus y equals 10. So the bottom didn't change at all, but the top, everything was multiplied by 4. Make sure you multiply everything. You don't just want to multiply the x and keep it as 3y and 9. You need to multiply everything. Now that I have that, I have them lined up. One of the coefficients are identical, so I'm going to subtract once again. So 4x minus 4x, that's 0, so it goes away. 12y minus -y, we're minusing a negative, so it becomes a plus. So we have 13y, and then 36 minus 10 is 26. We have that equation, so y equals 2 because I've just divided by 13. Now that I have that, again, I'm only halfway through the question. I'm going to substitute it into the top one this time because, again, it's just got smaller numbers. I could have substituted into the bottom one and it would give me the same answer. So I've had x plus 3 times 2, which is 6, and that equals 9. But now to get rid of that, 6, I'm going to subtract. So I get x equals 3, and that's my answer. Now I just want to be clear, once again, in this previous question, I lined up the y's and made them identical, and I eliminated the y's. In this question, I lined up the x's and made them identical to eliminate the x's. It doesn't matter which way you do it. You can either decide to eliminate the x's or eliminate the y's. As long as the multiplication you do to make it equal, like make the coefficients identical, is correct, and you subtract them correctly and all that, you would get the same answer. Like if I chose to eliminate the y's first rather than the x's, I would have found x equals 3 over on that right side. And once I found x equals 3 and substituted into one of those things, I would have eventually found that y equals 2. So the order in which you do these things doesn't matter as long as you do it correctly. Going on to this next one, what we have here is, again, they're lined up but neither of them are identical. So what we'll do is we'll look at multiplying one of them across. I'm going to choose to multiply the top one because 5 and 3, there's no easy way of doing it without having to multiply both of them. Like I could multiply the top by 3, and I could multiply the bottom by 5, and that would give me 15m on both of them. But that's just going to be a bit too much work. Why would I do that when I can just multiply the top by 2? Because then I have -4 on the top and bottom. So that's exactly what I'm going to do. So when I multiply the top by by 2, sorry, not by -2, I'll get 10m minus 4m, and that equals 40. And then I'll have 3m minus 4n, and that equals to 12. So I didn't change the bottom, I've only changed the top. Now you might be thinking, well, you can't do that because when we subtract them, they're not going to go away because now you're negatives. Or you might be confused, like you might be thinking they might be a bit different here. Nothing is going to change, right? We're still going to have, like, as long as they're identical, when we subtract, it will go away. And when you think about it, what we're going to be doing here is -4 minus -4. And remember, the negatives become a plus, so that becomes -4 plus 4, and that does equal 0. And that's what we're trying to do. This is why we make them identical. Because when we subtract something by itself, it goes away, it becomes 0. So that's the whole point of making them identical. So what we're going to do here, again, now that they're lined up and the ends are identical, mean that we're going to be eliminating the ends first. And now we just subtract, so 10 minus 3 is 7m. The ends go away. 40 minus 12 is 28. So then we have m equals 4. And once we have m equals 4, substitute it into any one of these. Now none of these are very nice. They all have a bunch of numbers and stuff. I'm going to substitute into the bottom one on that left side. So I have 3 times n, which is 12, minus 4n, and that equals 12. From there, I'll do 12 minus 12, because I need to get rid of that 12 first. So I have negative 4n equals 0. And then lastly, I'll divide by negative 4, but it's just going to be 0. So n equals 0. By the way, a way that we can check to see if our answer is right, like I've said in the past, is substitute these two numbers, n equals 0 and m equals 4, into any one of these equations that I have along the top, and it should work. So if I substitute into the very top left one, 5 times m minus 2n equals 20, well 5 times 4 is 20, and then 2 times n, 2 times 0 is 0, so I'm basically saying 20 minus 0, which does equal 20. So because it fits that equation at the top left, that means it works. One last question, and this is similar to that second one that we did, where we have the x's are almost identical, except one's positive 3 and one's negative 3. We could look to do something with the y's as well, but again, that will be multiplying the top by 2 and the bottom by negative 5. So to save us from doing 2 multiplications, just think a bit ahead and think, well, is there a way that I can do this equation with only 1 multiplication? And there is. So doing this one, I'm going to multiply the bottom by negative 1. And I'm multiplying by negative 1 because right now I have negative 3, but I want positive 3. So if I multiply everything by negative 1, I'll get rid of that negative. So 3x plus 5y equals negative 11. That top stays the same. I haven't changed it at all. And then if I do negative 3 times negative 1, that equals 3x. If I do negative 2 times negative 1, that's positive 2y now. If I do 8 times negative 1, that's negative 8. Essentially what I'm doing is I'm flipping the signs. I'm not flipping the signs, I'm changing the signs. And now they're in line. The x is identical, so I can start subtracting. 5 minus 2 is 3, so we get 3y. And then negative 11 minus negative 8 is negative 3. And then so y equals negative 1. And now there you have y equals negative 1. Again, just substitute it into any one of these. I'm going to substitute into that top left one. So I have 3x plus 5 times negative 1. 5 times negative 1 is negative 5. And that equals negative 11. And then going from here, I need to get rid of negative 5 first of all. So I get 3x equals negative 6. And then x equals negative 2. Alright, so this is just 4 questions going through simultaneous equations, but I mean if we flip through each of these slides for a second, you see that they almost all look the same, like in the terms of the process. And this is what I've been trying to emphasize over this whole chapter of equations. These processes stay the same. As long as you're doing the correct mathematics in terms of multiplying and subtracting, solving the equations, all that kind of stuff, you will get it right every single time. There's no trick questions here. There's nothing changing a little bit. I'm just making sure that they line up, that one of them are identical, then I subtract to eliminate one of them, and then I solve the equations. So anyway, hopefully this has been helpful, and make sure you, as you're watching this video, you've been going through the answers yourself, writing them down, or maybe even checking them. I realize that's not very useful to say that at the end of the video, but whatever. Anyway, thanks.